Hi guys, today we are going to discuss the 21st MCQ of 2019 A-Level chemistry paper. So this question comes from the 13th lesson, that's the equilibrium lesson. Okay, so let's start the video. Okay, now you saw the question. All right, now this question is exactly coming from the ionic equilibrium part of your equilibrium lesson. So it's talking about buffer solutions, right? Buffer solutions. Right, now this buffer solution, here you have monobasic weak acid and salt, the sodium salt of the acid. So that is very classic, right? Very classic. So what is the normal equation that we are going to use in such a question, such classical question? Yeah, obviously you are correct. That is Henderson-Hasselbalch equation. That is given in your syllabus also. So pH equals pKa plus log what you're going to write, like salt, maybe salt concentration divided by the acid concentration, or else you can just write down A minus concentration here and HA concentration here. That is very classic approach of approaching this question, right? So what do we have here? We have a pH 5 buffer, so that means here it is 5, right? And the concentrations are given. The salt concentration is 0.1 and the monobasic weak acid concentration is also 0.1. That means these two, like here 0.1, here 0.1, so those things will be cancelled off. So log 1 is 0, right? Log 1 is 0, so pH equals pKa. Here you have 0, so that means pH equals pKa. So your pKa will be 5. pKa is 5. That is for the buffer. Alright, that is for the buffer. So now we are going to the real question here. Alright, so in the real question they are asking the pH of the resultant solution. Alright, resultant solution. What resultant solution? When 20 milliliters of this buffer solution was mixed with 90 milliliters of 0.1 molar weak acid solution. Alright, let's draw some kind of a diagram. Alright, now here we have like this 20, here 20, here you have 90 milliliters. So what is the 90 milliliters? 90 milliliters is like a weak acid solution, let's say HA. Right, now this 20 milliliters is this buffer, you have 20 milliliters. So in this buffer, you know that the salt and acid concentrations are equal in that buffer part, so this 20 milliliters contain 10 milliliters of this salt and 10 milliliters of this acid, correct? So here you have 10 milliliters of HA and 10 milliliters of what? A minus. Let's say A minus. A minus is the salt, HA is the acid. Normal nomenclature, right? You just write down the monobasic acid like HA, and the sodium salt of that monobasic acid is just, you can write down A minus, sodium NaA, right? So here 10 milliliters of HA, 10 milliliters of A minus, and 90 milliliters of HA. So this whole thing contains how much? 10 milliliters of like, let's say A minus concentration is proportional to 10 milliliters. Why do I write down like proportional? Because we don't need actually to calculate this thing, because this is an MCQ, right? This is an MCQ. Why we are going to calculate everything, right? This is just proportional, because here we have a ratio, right? We have a ratio, so we don't have to actually calculate everything to the point. Okay, get it? Because this is an MCQ. You don't need to have longer calculations to solve a simple MCQ like this, right? A minus concentration is proportional to this 10 milliliters, and you have HA concentration in the resultant solution. I'm talking about this resultant solution, okay? This resultant solution, HA concentration is proportional to the addition of 90 plus 10 of the whole volume of HA. So 100 milliliters. This is proportional. Okay. So the rest is very simple. Remember, I forgot to mention one thing, that I took this proportional sign here just because everywhere you can see the weak acid concentration is given as 0.1. 0.1. In the whole question, everywhere you can see a concentration, that concentration is 0.1. Okay, the concentration is constant. That's why I put this proportional sign. You will get it if you really work out the question. This concentration, I mean, let me calculate this thing and show you the answer, and then I will show you the long method. Okay, now I can plug these two like this, 10 and 100 into here, and pK is now known. Then you can calculate the pH, right? So let's calculate. pH is equal to 5 plus log HA is 100, so here 100, here 10, right? Then what? Log 1 over 10, that means minus 1. So 5 minus 1, that is 4. pH is equal to 4, so the answer is 2. So okay, and I will show you how did I will justify why did I take these 10 and 100 into here. Okay, so let's calculate the actual A minus concentration in this resultant solution. Actual A minus concentration. So let's calculate. All right. Now I will show you the. I will justify my answer. Right. So let's write down A minus concentration is 10. Like what is the number of moles here? A minus moles. All right. That is 0.1, because in the buffer, in the previous buffer, they had 0.1 moles per decimeter cube, right? And we took 10 milliliters of A minus, 10 milliliters. So that means 10 into 10 to the minus 3 cube. Okay. So this is the number of moles of A minus in the resultant solution, and we have to divide it by how much? We have to divide it by the total volume, right? Total volume. What is the total volume? 110, right? This is 10, 10, 20, 20 plus 90 is 110. 110 into 10 to the minus 3. All right. So this is the actual A minus concentration. So what you will get? What you will get? I mean, this is a long calculation, right? So we don't have to actually solve this. I will show you the HA concentration, the actual HA concentration. That is also 0.1 moles per decimeter cube, which is coming from the buffer. There you have 10 into 10 to the minus 3. This is the buffer volume, HA buffer volume, which contains the HA, right? And plus this is the number of moles coming from the buffer, and you have here also HA, right? The number of moles. How to calculate the number of moles? There also the concentration is 0.1 moles per decimeter cube. And what is the volume you have? 90 into 10 to the minus 3 decimeter cube. Alright? And you have to divide this whole thing by the total volume. Total volume is this 110. 110 into 10 to the minus 3 decimeter cube. Okay, now solve this. This is A minus, this is HA. So you have to divide this by like this. Alright, so everything will be cancelled off. 110 will be cancelled off, and you have to you can just add them up, and you will get 0.1 in something, and finally the ratio is 1 over 10. Right, so this 1 over 10 we plugged in there, and we get here -1, and here we have 5 minus 1 is 4. That is how we got the answer. So this is the long method which you will have to work out in your essay paper, but not in here, right? Here we solve MCQs. Okay, here we solve MCQs. All right, thanks for watching. Subscribe to my channel, so you can look at so many MCQs like this, and join our Telegram group, so you can let me know your questions, and I can work out on those questions in my next video. All right, okay, bye bye.